This video will demonstrate how to compute p-values for the z-test using a standard table. A quick definition for a p-value: it's a statistical measurement used to validate a hypothesis against an observed value. We typically compute the p-value using the tail area of a test point. It is then compared to the level of significance, which is denoted as alpha. If the p-value is less than or equal to alpha, then reject H0, also known as the null hypothesis. But if the p-value is greater than alpha, do not reject H0, the null hypothesis. So let's take a look at an example of computing a p-value for a z-test. The first example will be when we have a right-tailed test. Let's assume that the following hypotheses were derived from a problem. H0 is mu equal to 5, H sub 1, mu is greater than 5. Let's also assume that we computed the test point using sample data and it's equal to 2.34. Well, the p-value would be the tail area to the right of the test point 2.34. So to find this tail area, we would have to look up 2.34 in a statistical table. So if we look up 2.34, we have, let's see, 2.3, 0, 1, 2, 3, 4. This table would give us the area to the left of that z value, which we found to be 0.9904, but we want the right tail area. So 1 minus 0.9904 is 0.0096. Since it's a one-tailed test, this is the p-value. It is 0.0096. We would then compare it to alpha. Now, if we have a two-tailed test, let's assume that we have a two-tailed test. In that situation, let's say we have H0 is mu equal to 5 and H sub 1 is mu not equal to 5. So if we look at H sub 1, when we see the not equal to symbol, that indicates we have a two-tailed test. Let's also assume that the test point is 3.02. Then the p-value, we have to find the combined tail area that's to the left of negative 3.02 and to the right of 3.02. That will equal our p-value. So what we do is we label the 3.02, and since it's two-tailed, we have a negative value on the opposite side, negative 3.02. What I typically do, and we're just using symmetry to write down these two values, and we're doing this because it's a two-tailed test. Then we can look up the area to the left of negative 3.02 using the table. Negative 3.02, 0.0013. That is this left tail area. Using symmetry, the right tail area is also equal to 0.0013. The next step is we add the two areas together, and that will equal the p-value, 0.0026. Finally, we could also have a left-tailed test. In this example, we're testing p is 0.17 for H0, and for H sub 1, p is less than 0.17. We have to be very careful because we don't want to confuse the p-value with p. In this case, the parameter p is being tested. We don't, like I said, we don't want to confuse it with the p-value. P is the population proportion. So please avoid the confusion. When you see a p, it is the population proportion, not the p-value. Let's assume we computed a test point for this test. It was negative 1.87. It is a left tail test. So we have negative 1.87. We need to find this left tail. We look up negative 1.87 in the table. So we have negative 1.87 is 0.0307. And since it's a one-tail test, this tail area is the p-value. Now, when we have to find the p-value for a t-test, it's better to use MS Excel or a TI graphing calculator or some other technology. You could check out one of my other videos that demonstrate how to find p-values for the t-test. Thank you for watching.